Good morning children and welcome back to your chemistry class. We were doing chemical bonding and molecular structure, and in the previous two videos we had discussed about the electronic theory. We have already finished with ionic bonding and we were doing covalent bonding. So today we are going to discuss about some of the factors which favor the covalent bonding, right? So the first point that favors covalent bonding is high ionization energy. Now the atoms having high values of ionization energy, right, they prefer to form covalent bonds. Why? Because they are unable to lose their valence electrons easily to form the cations. Then second point is that the equal electron gain enthalpies. Equal electron gain enthalpies. What do we understand by this? That is, the formation of the covalent bond is always favored when the combining atoms, they have equal electron gain enthalpy. What do we mean by equal electron gain enthalpy? It means that equal attraction for the electrons. Both the atoms, the non-metals, they should have the equal attraction for the electrons. Then the third point over here is equal electronegativities. Equal electronegativities. That is, both the atoms or both the non-metallic atoms, they should have equal electronegativities. An atom will not transfer the electron or electrons to the other atom if the electronegativity difference between the two atoms is 0 or it is very small. So such atoms, they prefer to share electrons, that is, they form the covalent bonding. Clear? Then we come to the fourth point, that is the number of valence electrons. Number of valence electrons also play a very important part in understanding which kind of bonding it is going to show, right? That is, the formation of the covalent bond will always be favored when each of the combining atoms, it contains the valence electrons as 5, 6 and 7, because 1, 2, 3 they are going to show ionic bonding, right? 5, 6, 7 electrons in the valence shell, they show covalent bonding, right? And this is why electrons, they belong to which group? 15, 16 and 17, and they easily form the covalent bonds. Fifth important factor which favors covalent bonding is high nuclear charge and small internuclear distance. That is, high nuclear charge. More the nuclear charge, more is the condition favorable for covalent bonding. High nuclear charge and small intermolecular distance. Okay. So during the formation of a covalent bond, the electron density, it gets concentrated between the nuclei of the combining atoms, correct? So this electron charge, that is responsible for holding the two nuclei together. Therefore, higher the nuclear charge and smaller the intermolecular distance between the two atoms, this is going to favor covalent bonding. So these are some of the factors which favor covalent bonding. Now we are going to understand a new term that is called as covalency. We will also understand what is variable valency, and we will also try to understand what is maximum covalency. Now let us understand what is covalency. Okay. So when both the atoms, they are short of electrons in the valency shell in comparison with the stable noble gas configuration, then such atoms, they complete the outermost shell by sharing of the electrons. So except hydrogen, right, except hydrogen, which has only one electron in the valence shell, such atoms have 5, 6 or 7 valency electrons. So all the non-metals of your group 15, 16 and 17, they satisfy this covalency. So how can we define what is covalency? It is defined as the number of electrons that are contributed by an atom of an element for sharing with the other atoms and to achieve a noble gas configuration. That is called as covalency. Clear? So I am writing it down over here. It is defined as the number of electrons contributed by an atom of the element for sharing with other atom to achieve the nearest noble gas configuration is called covalency. I hope this is very clear to you. So the usual covalency of an element except hydrogen, again I am saying whose covalency is 1, is always equal to how much? It is 8 minus the number of the group to which an element belongs. Okay, so that is called as its covalency. This is not for hydrogen, but it is for all other atoms. Clear? So now generally the covalency of an element, it is always equal to, as I told you, the total number of unpaired electrons in the s and the p orbitals of the valency shell. So let us take certain examples and understand the covalency concept. So let's firstly start about with hydrogen. Hydrogen has one unpaired orbital. How? Let's see. This is 1s. So atomic number 1, valence electron 1. So this is what it is going to show. So over here covalency is also equal to 1. Right? Next let's talk about fluorine. Fluorine, it has also one unpaired orbital. What do we know about fluorine? Its atomic number. So let us find out the configuration for fluorine. It is 2s and this is 2p. Okay, so 2s2, 2p, 5. 5 means 1, 2, 3, 4 and 5. So how many unpaired? 1 unpaired. So over here also covalency will be 1. Right? Let's talk about oxygen. Oxygen, let us look at this also. So this is 2s, 2p. 1s2, 2s2. 2 means 2. And how much left is 4. So 1, 2, 3 and 4. What is the covalency? 2 are unpaired. Therefore over here covalency is 2. I hope you are trying to understand. Let's talk about nitrogen also. Over here what are we going to see? This is 2p and this is 2s. 2s2, 2p3. 1, 2 and 3. Here 3 unpaired p orbitals are there. So over here the covalency of nitrogen will be 3. So these 4 elements, they do not possess the d orbitals in their valency shell, right? So the elements having vacant d orbitals in their valency shell, they are, for example, phosphorus or sulfur, chlorine, bromine and iodine. They all show variable valency. Why? Because the electrons, they move to d orbitals, and where we are going to see the vacant d orbitals. So they show, these elements, they show variable valency. So first point we have understood what is covalency. Now we are going to talk about variable valency, then we are going to talk about maximum valency. So let us begin with the variable covalency of phosphorus, sulfur and chlorine. So we are going to understand this also. So let us begin with the phosphorus. How to find out the variable valency of phosphorus, right? So phosphorus, it shows what two valencies? 3 and 5 covalencies, right? So let's see phosphorus atom in the ground state. So in the ground state, how do we configure phosphorus? It is 3s, 3p, this is 3d. Okay, so now let us look at phosphorus. Phosphorus, we know that it is 3s2 and 3p3. So 3 means 1, 2 and 3. So what do we see over here? 3 unpaired electrons over here. So presently at the ground state, its covalency is how much? 3. Clear? Now let us look at the excited state of it. Excited state of the phosphorus. So in the excited state, what will happen? All these paired electrons have to be filled up in the vacant orbitals, right? So over here it is paired. So 1, this is 2, 3, 4 and 5. Here now we have how many? 5 unpaired electrons. So over here the covalency is 5, and therefore you can see the phosphorus, it shows 3 and 5 as its covalencies. In the ground state we find covalencies 3. In the excited state we find the covalency of phosphorus is 5. So the phosphorus, it shows variable valency of 3 and 5. I hope this is clear to you. Now let us talk about sulfur. This was about phosphorus. Now I'm going to talk about sulfur. Okay, so sulfur, it shows what? It shows how many covalencies? It shows 2, 4 and 6 covalencies, right? So let us look at the sulfur in the ground state. Okay, so sulfur in the ground state, this is your 3s, 3p, 1, 2, 3, 4, and this is 3d. Okay, so 3s2, 3p4, 1, 2, 3 and 4. So what do we see over here? 2 unpaired electrons are here. So covalency is what in the ground state of sulfur? 2. Now let us look at the first excited state. First excited state. In the first excited state, what are we going to see? Firstly, 3s2 remains as it is. Let's look at P. And I draw d orbital also. 1, 2, 3, 4, 5. So now this is 3s2. Now this electron is going to go to the next orbital. So this becomes what? 1, 2, 3, 4. So now look at the number of unpaired electrons. 1, 2, 3, 4. So in the first excited state, the covalency of sulfur is what? 4. So we got 2, we got 4. Now we have to find out 6. So let's look at the second excited state. Okay, this is 3s2, 3p, and this is 3d. 1, 2, 3, 4 and 5. So now this has to go and occupy the vacant orbital. So this is 1, 2, 3, 4, 5 and 6. Now how many unpaired electrons do we have? 6. So in the second excited state, the sulfur shows 6 as the covalency. I hope you have understood all this. Now, know about chlorine. Chlorine shows, its covalencies are what? They are 1, 3, 5 and 7, right? So you are going to find out for chlorine, as in the ground state first, you will get covalency 1, first excited state 3, second excited state 5, and the third excited state you are going to get 7 as your covalency. So this you have to draw and do it on your own to see how much you have understood. Now let's talk about what do we mean by maximum covalency, right? So the maximum number of covalent bonds that one atom of an element can form, it is referred to as the maximum covalency of that particular element, right? So the maximum covalency of an element is actually what? The number of unpaired electrons that an atom of the element it acquires after promoting all of its valence shell s and p electrons into which one? D orbitals, as I showed you for the sulfur one, and what you will find out for your chlorine as well. So the maximum covalencies of your phosphorus, sulfur and chlorine, what are they? They are for phosphorus, if you remember, in the first excited state we got covalency 5, so that is the maximum covalency. For sulfur we reached to the second excited state, so the covalent there we had calculated, it was 6. For chlorine, how much? That you will find out and give an answer to yourself, right? I hope this maximum covalency is clear to you. Now we are going to talk about the characteristics of covalent compounds. The characteristics of covalent compounds. Now let's talk about its physical state first and foremost. What do we know about the physical state of covalent compounds? Under normal conditions of temperature and pressure, okay, the covalent compounds, they exist as at normal temperature. The covalent compounds, they exist in what form? They exist as as gases or liquids of low boiling point. Okay, why this is so? It is due to the weak forces of attraction. Why is it so? Due to van der Waal forces. I hope you know what are van der Waal forces. That are the weak forces that exist between the molecules, right? So some exist as soft solids. If their molecule masses, they are little higher. Like for example, sulfur, phosphorus, iodine, they are all your soft solids. Then let's talk about the melting point and the boiling point of covalent compounds. Now you already know that these compounds, they show weak van der Waal forces, right? So their melting boiling point is less than ionic compounds. Why? As I told you, due to the presence of weak forces. What are those weak forces? Van der Waal forces. And so on supplying heat energy, what will happen? The molecules, they are readily pulled out from their forces and they move out freely and and thus they show lesser melting and boiling point as compared to ionic compounds. I hope this point is clear. Let's talk about electrical conductivity. Now, what do we know about electrical conductivity? These covalent compounds, they are bad conductors of heat and electricity. Clear? Substances which have polar character. Substances having polar, character. Polar character. For example like HCl. In the solution only. If it is in the gaseous state, it will not allow electricity to pass through. But if it is in its solution state, that is, water is present in it, right? Then it conducts electricity. HCl in the solution conducts electricity. Clear? So covalent solids, they have giant molecules and they are all bad conductors. Why? Because they do not contain charged particles or they do not contain free electrons. So the graphite, it can conduct electricity. Why so? Because electrons, they can pass from one layer to other. If you remember, one carbon is attached to 3 other carbon atoms and one electron is left free, which allows electricity to pass through. Then let's talk about solubility. What do you know about the solubility of the covalent compounds? Covalent compounds, they are insoluble in polar solvents. Okay, insoluble in polar solvents, but soluble in non-polar solvents. Clear? So those non-polar solvents, if I say, what do I mean by non-polar solvents? I mean like benzene and so on, carbon tetrachloride, CCl4, etc. So what are they based on? Their principle is based on like dissolves like. So some of the covalent compounds like alcohols, they dissolve in water due to hydrogen bonding, remember. But these covalent solids, since they have the giant molecules, they are practically insoluble in polar solvents, right? Next we talk about the molecular reactions. Let's talk about the molecular reactions. Molecular reactions. These covalent substances, they show molecular reactions. Remember, the reaction rates, they are usually low with respect to the ionic reactions, because they involve two steps. What is the first step? First step is breaking. First step is the breaking of the covalent bonds, right? And the second step is what? Establishing new bonds. So we can say that covalent bonds, they show molecular reactions which happens in two steps. First is breaking of the covalent bond, and second one is the establishing of the new bonds, and thus they are less reactive than ionic reactions. And lastly, what I remember, we talk about isomerism. What do we know? These covalent bonds, they are hard, rigid, they are directional. So there is a possibility of arrangement of atoms in the space, and therefore we can say that these covalent compounds, they can show isomerism. I hope you know what is isomerism. It has a similar molecular formula but different structural formulas. I hope till here everything is clear. They show isomerism, right? Now let's talk about, now I'm going to discuss about comparison between ionic and covalent compounds. Let us understand. Now till now we have discussed so many points. Let's put all these points together to understand what is the difference between ionic and covalent compounds. So hear it carefully because I'm not writing it down. So if we talk about ionic compounds, firstly we are going to talk about ionic and then I'll talk about covalent. So ionic compounds, you know, they are crystalline solid at room temperatures, whereas just now I told you about covalent compounds that they exist as gases or liquids or even soft solids under ordinary conditions, right? Now ionic, they have high melting and boiling point, whereas if we compare it with the covalent compounds, they have low melting and boiling point with respect to ionic compounds, right? Then we also know that ionic compounds, because of electrostatic force of attraction, they are hard and brittle, but covalent compounds, they are weak van der Waals forces are present over here, so they are soft, waxy, right? Then exception is there, giant molecules exception is there, but still they form soft and waxy compounds. This ionic compounds, they are soluble in water and in polar solvents, right? But they are insoluble in non-polar compounds. The covalent compounds, they are soluble in non-polar compounds, but they are insoluble in polar solvents, right? Then what else do we remember about ionic compounds? That is, ionic compounds, yes, in their solid state, they are bad conductors of heat and electricity. They only allow electricity to pass through when they are in the molten or in their aqueous state. Whereas what do we know about covalent compounds? Just now I told you that these are all bad conductors of electricity, right? Except the graphite. That is an exceptional example. And last but not the least, just now we were talking about molecular reactions and isomerism. Then all these ionic compounds, they undergo ionic reactions, means the rate of reactions are very high over here. They are fast, they are instantaneous. Whereas covalent compounds, they undergo molecular reactions. Molecular reactions happen in two steps, therefore rate of reaction is also slow and the reaction also goes very slow. I hope this is clear. Then ionic compounds, they do not show isomerism, whereas covalent compounds, they can show isomerism. So these were some of the differences between ionic and covalent compounds. Now I would also like to discuss comparison between ionic and covalent bonding. Now this is equally important. We were discussing about compounds. Now let us talk about bonding. So once again I'll talk about ionic and then I will talk about covalent compounds, covalent bonding, but again I'm not writing it down over here, so you have to lend your ears to understand this. So let's talk about ionic bonds. They are always formed how? By the transfer of electrons. From where? From metal to non-metals, right? Whereas in covalent bonding, what did we see? There is sharing of electrons between two non-metals which equally contribute electrons. Then in ionic bonding, the bond is possible only and only between dissimilar atoms, whereas in covalent bonding it can be possible with the similar atoms as well as with the dissimilar atoms. Then what do we know about ionic bonding? There is electrostatic forces of attraction between the atoms here, whereas in covalent bonding they consist of shared pair of electrons. They even contain the lone pairs, right? And yes, then coming to ionic compounds, they are non-directional, whereas just now I had told you covalent compounds, they are directional, okay? And therefore they always form isomerism, whereas ionic compounds or ionic bonding, they do not show isomerism at all, okay? Then talking about something more, ionic compounds, they are polar in nature, covalent compounds are non-polar in nature, right? If remember, electronegativity difference is 0 or smaller than that. Then in ionic bond, anything else here, right? Ionic bonds, they are weak bonds. Reason being, since the electrostatic forces between the ions, they can be broken easily over here. But covalent bonding, it is a strong bond. Why so? Because the paired electrons, they cannot be separated easily. You try to understand in this form that ionic bonding is that 2 plus positive and negative ions, they are brought together, so they can be easily broken. But in covalent bonding, what happens? There is sharing of electrons, so this is little hard to separate, and therefore we can say that the covalent compounds, they show strong bonds, and ionic bonding, they show weak bonds. So these comparisons both are clear between ionic covalent compounds and even ionic covalent bonding. Now let us understand what is a formal charge. Okay, so in the what is a formal charge? Now the formal charge, it is a virtual charge which these constituent atoms of a molecule, they may appear to have when the valence electrons or lone pair electrons and the bonded electrons, they are assigned to each atom according to certain rules, right? That is called as formal charge, or in other words we can define it as the formal charge on an atom in any of your polyatomic molecules or ions, they may be equal to the difference between the number of valence electrons possessed by that atom in the free state and the number of electrons assigned to that atom in the Lewis structure of the molecule or ion. So this is called as your formal charge. Now there are certain rules that we need to follow. Firstly, before telling you the certain rules that this formal charge, to calculate the formal charge, we first need to know what information does this formal charge give. So they are helpful in keeping the track of the valence electrons in the Lewis dot structures of the molecule, and they are also considered to be the most stable if the formal charges on the atoms, they are minimum, and the negative formal charges on the most electronegative atom. Now I'll show you how and what you have to do. So formal charge on an atom in the Lewis structure, you have to just learn the formula, which is equal to number of valence electrons of the free atom minus the number of lone pairs of electrons minus half the number of bonded electrons. Okay, so this is the formula to find out the formal charge. Now, certain rules are there for calculation of the formal charge. What are they? That all the non-bonding electrons. Now, what are the non-bonding electrons? All non-bonding electrons. So what are those non-bonding electrons am I talking about? I'm talking about those unshared electrons. I'm talking about the lone pairs. I'm talking about the unbonded valence electrons. These are all assigned to the atom on which they are found, right? So all non-bonding electrons are assigned to the atom on which they are found. Clear? Then second important point, each atom in a bond, it is assigned half of the total number of electron it shares in the bond. Clear? So over here, each atom in a bond is assigned half of the total number of electrons it shares in the bond. Clear? For example, say for a single bond, each atom is assigned how much? 1 electron. For double bond, each atom will be assigned 2 electrons. For triple bond, 3 electrons, and so on. Right? So the general formula for finding out formal charge, it is equal to NV minus NUB minus half NB. Now I'll tell you what are these. Over here, NV, it is the number of valence electrons in the free atom. Okay. Then what do you have? NUB. NUB, what is this? It is the number of unbonded valence electrons, right? And then we have NB. What do we mean by NB? These are the number of bonded electrons around the atom. So this is actually the formula that you have to learn to find out the formal charge. Clear? And what are they? I have already mentioned it over here. So let us find out one question where we are going to calculate the formal charge of a particular ion. Let's take one example. Like we have to assign a formal charge to each atom of HCN, right? So we have to assign a formal charge to this compound, that is HCN. So now remember, first and foremost you have to draw the Lewis dot structure of this particular molecule, and then you are going to calculate the different types of electrons on and around each atom, and finally we are going to calculate the formal charge. Now you are going to see how I am going to calculate the formal charge over here. First, let us make the Lewis dot structure. So H, right? Then C means what? 1, 2, 3, 4. And nitrogen means what? Nitrogen is 5. So 1, 2, 3, 4, 5. Clear? So this is your Lewis dot structure. So Lewis structure, it can also be written as what? H combines with a single bond. Correct? This single bond and nitrogen requires 3 electrons, and 3 electrons are vacant over here. So carbon will attach itself with how many? 3, and the lone pair is found over here. So this structure can be written like this also. Now let us see the electrons and the formal charge on N atom. I'm talking about N atom, and revise the rules that I told you for calculating the formal charge. So over here, number of valence electrons are equal to how much? NV, which is equal to 5. Okay. Then number of unbonded valence electrons, they are equal to what? NUB, which is equal to 2. Unbonded electrons are how many? 2. And number of bonded valence electrons, that is NB. This is equal to what? 6. Because how? 3 from here and 3 from here, 3 from carbon, 3 from nitrogen, they are bonded. So that makes it 6. Now what is the formula? What formula did I told you? Formal charge is equal to NV minus NUB minus half NB. This was the formula given to you. So let's write down what is NV. 5 minus NUB, 2 minus half into 6. This is 3. This gives you what? 5 minus 2 minus 3. So this is equal to 5 minus 5, which is equal to 0. So what is the formal charge on nitrogen that we find? It is 0. I hope this is clear. Now let's find out for carbon and that for hydrogen. So next one is electrons and formal charge on carbon atom. Let's look at this. So number of valence electron, NV, is how much? Equals to 4. 1, 2, 3, 4. Okay. Then what is the number of unbonded valence electron? That is NUB. This is equal to 0. All are bonded, 1 with this and 3 with this. And then what is your number of bonded valence electrons? Number of bonded valence electrons are how many? There are 2 with the hydrogen, 1, 2. And how many with nitrogen? 1, 2, 3, 4, 5, 6 plus 6. This is equal to 8. Now use this formula. 4 minus 0 minus half of 8. So 4 minus 4. This is equal to 0. So at carbon also your formal charge is 0. Now let us find out electrons and formal charge on hydrogen atom. Let's find out for hydrogen. So quickly the number of valence electrons, this is equal to 1, right? Then number of unbonded electrons, valence electrons, that is NUB, it is 0. And what about the number of bonded valence electrons? That is NB. How much? It is 2, because 2 electrons are present there which are bonded. So quickly put it in your formula. 1 minus 0 into half of 2. So this becomes 1. So 1 minus 1, which is also equal to 0. So hydrogen also formal charge is 0 over here. So have you understood what are the formal charges on each atom of HCN? It is 0. So this is how we calculate the formal charge. Now I am going to give you a little homework and then wind up with the today's video. Now you have to find out the formal charge for number 1, a carbonate ion, and you have to find out the formal charge on nitrate ion. Okay, so here you have to find out the formal charge on carbon as well as oxygen, and here on nitrogen as well as oxygen. Before I wind up, just would like to tell you that the formula with the lowest magnitude of formal charges, they always have the lowest energy and they are the most stable compounds. Okay, so formula with lowest magnitude of formal charges, they have the lowest energy and are most stable. Clear? So that is all for today, and this is your homework which you are going to do. Thank you.